Today we will be going over the 2023-2024 DPM review. This is a voiceover, so there will be really weird moments of silences. During these silences, you're able to answer the question on your own. Today we'll be finding the freezing point of ethane glycol solution, right? So you're going to be using the freezing point depression formula, IMFK freezing point. Take this time to now try to answer this question on your own. Okay then, we're going to be using 1.7 validity times 1.8 cm, right? And that's just going to basically give you 3.06. You're not quite done yet though. You're then going to subtract 3.06 by 0, so 0 minus 3.06, and that will give you your freezing point of negative 3.06, as you can see as I'm writing it out. Degrees Celsius, of course, don't forget your degree. Okay, and now we're doing molar solubility of calcium fluoride. Okay, KSP for CaF2 is 3.9 times 10 to the power 11 at 25 degrees Celsius. So as we wait for it to load up, I'm going to give you this moment to try to answer the question on your own. Once again, make sure you fully write out your formula before doing anything else. Okay, hopefully you had enough time. We're just going to do x 2x to the power of 2. And this is because the Ca squared, to the power of 2, and the x for CF2. Alright, that should equal out to 4x to the power of 3, right? You're then going to take 9.75 times 10 to the power of 2, which will then give you 3.9 times 10 to the power of 11, negative 11. And I'm pretty sure that's over 4x to the power of 3. So essentially, you add the 4 at the bottom so they both cancel each other out whenever that happens. Yeah. So they're both going to be square root of 3. So that cancels out. That's also to the 3. I just didn't write it. That's my bad. Is going to become x equals 2.1 times, if I'm correct, it's 10 to the power of negative 4. Okay, now this question is pretty simple. You just have to identify each one and what category they fall into. We'll give you a moment to do that on your own. Okay, so your first one is dipo. If I'm correct, your second one, your third one should also be dipo. Your very last one is going to have the highest temperature due to the H bonds. And that basically leaves your last one to have your lowest boiling point. Okay, starting off with question 4. Once again, I'm going to give you a moment to answer this question on your own, or at least to start it off. Okay, hopefully you had enough time. We're going to be using the formula of change in G equals change in H minus change in temperature times S. So as you can tell, we are given our change in H, which is 830 kilojoules over moles, right? You're going to continue on. We have, 200. I'm pretty sure it would be 225 and not 250, but 25 degrees Celsius. You're then going to just add 273 to get your Kelvin. And as you can see, SO is in joules moles was incorrect. You want to make sure that your kilojoules, like both of your units are the same, so they both need to be in kilojoules, or they both need to be in joules. So we're just going to convert our 161 by dividing it by 1,000 to get it into kilojoules. And you're going to multiply that. You're going to basically just plug it in, which is 161. And that should give you your change in G, which is going to be 782 kilojoules, which then just equals G. Okay, on to the next question. I'm going to give you a moment to try to start it on your own. Okay, once again, this is a very simple, very easy question. All you're going to do is convert that 36% into grams. Like, no matter what, if it's ever a percentage, you can usually convert it into grams. You're then going to take the molar mass, my bad. The molar mass of HCl, which is 36.45, 8 grams. You're going to divide the two to get your moles. From there, you're going to just divide that by your liters, which is 0.0847 liters. And then let me show you how to find that. Which then gives you 11.65 molarity. But in order to find 0.0847 liters, you are going to do 100 over ml times ml, and that's all over 1.18, right? Those are going to cancel out, which is basically gives you 100 over 1.18, which is just grams over ml. Right? So when you divide these two out, your grams are also going to just cancel away, which then leaves you with 84.754 ml. From there, you're just going to divide that by 1,000, and that gives you 0.847 liters. And that's how you do the process. I'm sorry, I know it's backwards, but you kind of get the method. Once again, here's the next question. We're going to give you a moment to answer this on your own. Okay, so you're going to use KP is going to equal KC. KCR times T, change in moles, right? So once again, you can very easily find your temperature by doing 35 plus 273. We're going to start off with Kc though, so 6.45 times 10 to the power 4 times is 0.821. That's a constant no matter what, so that's going to be in your formula sheet on the back. And it's going to times your temperature, as I said before. That's just going to be 273 plus 35. It gives you 308. Alright, and all you do from here is just type this onto your calculator. It's super simple. So your answer can be 2,550.7 or 2.5507 times 10 to the power of 3. Once again, it's a very simple question. Take a moment to try to find it on your own. Really, to just solve these, you just need to know your orders. Zero order is obviously when concentration and time is decreasing at the same time. First order is when natural concentration and time are decreasing. And then second order is when concentration to the power of negative is increasing with time. So once again, the very last one is going to be your answer for second order. Okay, so on to the next question. I'm going to give you a moment to try to solve this on your own. Okay, so we're going to use HF positive equals Ka, A over B. Okay, so once again, you're just going to put the molarity of HF on top and then the molarity of KF at the bottom. Okay, we're going to move on. You're going to do H positive equals 7.2 times 10 to the power of negative 4. Yeah, and then you're going to do, as I said, HF, which is 0.6 on top, and then 1 at the bottom, which then equals out to 4.32 times 10 to the power of negative 4. Now we're trying to find pH, and I don't know if you remember, but the pH formula is negative log of H positive. We now know what H positive is, so you're just going to write out negative log 4.32 times 10 to the power of negative 4. And then basically put that into your calculator, which should just give you 3.36 pH. And that is going to be your answer. Also, to help you identify, remember, if it's 7 and above, it's a strong base. If it's less than 7, then it's usually going to be an acid. Okay, and now we're on to the next question. I'm going to give you a moment to answer this on your own. Once again, it's one of our easier questions. We go from zinc solid to zinc plus 2 electrons aqueous, and then we go from copper plus 2 electrons to copper solid. So as we can tell, copper is getting smaller while zinc is becoming larger. So zinc is our oxidating agent, and copper is our redox. Okay, on to the next question. This is also fairly simple. I'm going to give you a moment to try it on your own, or not, sorry, didn't give you enough time. But basically, as you can tell, rate is just K. A is doubled. A is the second rate, so it's A bracket squared bracket B. B is only 1 on the second side, so obviously it's b by itself. Okay, on to the next question. I'm gonna give you a moment. Okay, so you're basically gonna do Ka equals squared of Ha, which is basically your acid, right? We're gonna move on. You're gonna do 6.2 times 10 to the power of negative 10, and that's gonna equal x squared over 0.025. You're either gonna multiply both sides by 0.025 so they can cancel out on both sides. So what you do on one side, you do on the other, as shown here. Okay, that 0.025 cancels out. And so we'll rewrite your equation. 0.025 times 6.2 times 10 to the power of negative 10 is 1.55 times 10 to the power of negative 11, which just gives you x squared. You're going to want to get x alone, so you're going to square root both sides, and that gives you 3.9x times 10 to the power of negative 6, which equals x. But now we have concentration and we want the pH. So now we're going to do our pH formula, which is just negative log of H positive. And that's just basically negative log of 3.9x times 10 to the power of negative 6. And I'm going to give it a moment to load. And that gives you 5.4 as your pH level. And that's your answer. Okay, on to the next question. I'm going to give you a moment to answer, or at least start the question off. Okay, so we're doing natural log of A, which basically just equals negative K plus once again, natural log of A sub 0, right? So we're going to move downward. You're going to do 0.75. That's negative, that's your KT, right? You're going to multiply that by your time, which is just 2.8, plus your natural log of A sub 0, which is 0.25, because that's your initial concentration. And that's going to go ahead and give you 3.486. But you're not quite done yet, if I'm correct. A second to load. You're going to take natural log of A, that should equal negative 3.486, and then proceed to put E on each side. So you have A alone, which should just give you A brackets equals 0.0306, and molarity, and that should be your answer. Okay, on to the next question. I'm going to give you a moment to try it on your own. Okay, first off, you can always make sure we fully write our equation out. Okay, so that's going to be negative 2x on that side. On the here, we're doing our rice table. This is going to be 2. And then on the very last side, it's just going to be x. And then after that, we are going to do 0.08 minus 2x equals 0.02976. You're going to then subtract 0.08 off of both sides. Because what you do on one side, you do on the other. As always, you get negative 2x, which then equals 0.5024. Right? From there, we're just going to divide both sides by negative 2. And that should give you x equals 0.0215. Sorry, 25112. Yeah. That's your x. That's for CL. But also once again, we're trying to find NOCL. Oh, how many moles of NO and Cl2? So as you can see, 2NO is just 2x. So you're just gonna multiply 0.02512 by 2 to get NO. Okay, on to the next question. I'm going to give you a moment to answer it on your own. Okay, which of the following stressors would shift the following equilibrium towards the projects? So definitely removing heat. So yeah, we want to move towards the right. So if we remove heat and remove NO, that would definitely make it lean towards the right more than anything, because it's losing heat, which is exothermic, which also is going to make a shift towards whatever is missing, or whichever has the least amount of heat. So B is your answer. On to the next question. Once again, super easy. We have our pH at 25 degrees Celsius. Also, this is a strong base formula, so it's just going to be 14 minus 8.33, which is just pH pH plus POH equals 14. So when you subtract it, you'll get POH. See, once again, it's a strong base. And that gives you 5.67. And that just equals POH. From there, you're going to do POH equals negative log of OH. Right? But also, we're trying to look for our concentration, so we're looking for OH. In order to do that, to find OH basically equals 10 to the power of negative POH. Okay, so what we're going to do is plug in 10 to the power of negative 5.67. And that basically gives us our answer of 2.14. 2.14 times 10 to the power of 6. And that is OH. Okay, on to the next question. I'm once again going to give you a moment to answer this on your own. Okay, and in order to find moles, we're going to just do molarity, moles over solute over mass of solvent in kg. And that's going to be 0.00 molarity times, whenever it loads in, there it is, times 0.134, which then it's going to give you 0.67 moles. Because we don't have moles, and all we have to do is just multiply the two. From here, it's very easy to find conjugate acid and conjugate base pair for each. You're just going to figure out which one's your weak acid and your strong acid, and weak acid, and strong base and weak base, and then pair them up. Your weak base is going to go with your strong acid, and then your strong base with your weak acid. Okay, and then going on to the next question, I'm going to give you a moment to answer it on your own. Once again, it's super simple. NO2 is gaining and O2 is quite literally disappearing. So obviously it's going to be B, negative H, and negative S. Okay, on to the next question. I'm going to give you a moment to try to answer it on your own. Okay, so we're using the same formula as earlier. You're doing change in G equals change in H minus change in temperature times S. From there, you're going to make sure everything equals 0. You're going to do 136 minus, 136.5 minus temperature times 0.2875. We're then going to move our 136 on both sides, so we're subtracting 136 off of both sides. Which then leaves us with 136.5, and the opposite side equals negative T times 0.2875. We're going to divide 0.2875 off of both sides. Which then leaves us with 474.78 over 1. You're then going to plug in T on the other side, and then from there, all you're going to do is just look for which one matches the closest, and obviously it's going to be T is obviously going to be 475. Okay, on to the next question. Once again, I'm going to give you a moment to try to answer it on your own. Okay, so in here, magnesium is +4 and oxygen is -2. Our zinc is obviously going to be our oxidizing agent just because of how it's gaining electrons in the second half. And magnesium O2 is going to be our redox just due to how it's losing. Okay, on to the next question. We're basically answering these three here. As we identified before, it's obviously zinc that's oxidizing. How many electrons are transferred? And as we know, only 2 got transferred for zinc. And then what was formed at the antidote, that had to be zinc OH2. That is our antidote that formed. Okay. Here we can obviously see that aluminum is losing and copper seems to be gaining on here. So aluminum is going to be our antidote, which will decrease, and copper is going to be our cathode, which will increase. Okay guys, this is super easy, just try to memorize definitions. Fission is obviously breaking, and fusion is fusing or merging atoms. So as you can see, I wrote the definitions down. Fission is breaking down of atoms, and fusion is the merging of atoms. Or a combination of atoms. Okay, so once again, just try to memorize it the best you can. Alpha decay is going to be Pu, whenever it loads, Pu 239, my bad, and 94 at the bottom. And that's just going to transform into 235, 92 plus He 4 and 2. And then our beta decay is going to be, 234.90 TH, which then turns into 234.91 PA plus I beta. Okay, and that's your review for today. I hoped I explained everything properly, and I hope everything makes sense. If you have any other questions, just ask Dr. D.